What exactly is a rainbow? Most people would answer, a giant arc of 7 colors stretching across the sky after rain. But that answer creates a much bigger mystery. If a rainbow is a real object, why can nobody ever reach it? Why does it seem to move when we move? And why has nobody ever found the famous pot of gold said to be hidden at its end? Today, we're going to uncover the science behind one of nature's most beautiful mysteries. And by the end of this journey, you may never look at a rainbow the same way again.
Before we understand what a rainbow is, we first need to understand when it can appear. A rainbow does not form every time it rains. Several conditions must occur at exactly the same time. First, there must be countless tiny droplets of water suspended in the air. These droplets may come from rain, a waterfall, ocean spray, or even a garden sprinkler. Second, sunlight must be shining. And third, the sun must be positioned behind the observer, while the droplets remain in front. Without this precise arrangement, a rainbow simply cannot exist.
Have you ever noticed something strange? Large rainbows are far more common in the morning and late afternoon than they are at midday. Why? The answer lies in the position of the sun. At noon, the sun sits high in the sky. Because of this, the rainbow forms at an angle that often places most of it below the horizon. In other words, the rainbow is there, but much of it is hidden from view. As the sun sinks lower toward the horizon, the geometry changes. The rainbow rises higher into the sky, and suddenly, it becomes visible. A rainbow is not controlled by the weather alone. It is controlled by geometry.
Now that we know when a rainbow appears, let's zoom in on a single raindrop. Not a cloud, not a storm. Just one tiny drop of water floating in the air. At first glance, it seems insignificant. But inside this tiny droplet, an extraordinary journey is about to begin. Sunlight arrives at the droplet, appearing completely white. Yet white light is not truly one color. It is a mixture of many different colors traveling together. Red, orange, yellow, green, blue, indigo, and violet. As the sunlight enters the droplet, it slows down. And when light changes speed, it bends. Physicists call this process refraction. The rainbow begins with a bend.
But something even more interesting happens. Not all colors bend by the same amount. Red light bends a little. Blue and violet bend even more. The colors begin to separate. Very slightly at first, but enough to start revealing the hidden spectrum inside sunlight. After entering the droplet, the light reaches the back surface. And instead of escaping, much of it reflects from the inside wall of the droplet. The droplet behaves almost like a tiny mirror, a microscopic optical laboratory suspended in the air. And remember, This is happening not in one droplet, but in billions of droplets all around you.
After reflection, the light begins moving back toward the front of the droplet. To leave the droplet, it must pass from water back into air. And once again, its speed changes. And once again, it bends. A second refraction. This final bend spreads the colors apart even more. The red light emerges at one angle. The blue and violet light emerge at slightly different angles. What began as ordinary white sunlight has now become a spectrum of colors. Every rainbow in history, every rainbow ever photographed, and every rainbow you will ever see begins with this same sequence: refraction, reflection, and refraction again.
Now comes the part that surprises most people. A rainbow is not produced by just any raindrop. Only droplets positioned at very specific angles can send colored light toward your eyes. For red light, the angle is about 42 degrees from the direction opposite the sun. For violet light, the angle is slightly smaller, around 40 degrees. It may seem like a tiny difference, but it changes everything. Because red light leaves the droplet at a larger angle, it appears on the outer edge of the rainbow. Blue and violet leave at smaller angles, so they appear on the inner edge. The order of colors is not random. It is written into the geometry of light itself.
And now we arrive at one of the strangest truths about rainbows. The rainbow you see is not exactly the rainbow seen by anyone else. Not even someone standing right beside you. Your eyes receive colored light from one specific set of droplets. Another observer receives light from a completely different set. The droplets creating your rainbow are not the same droplets creating theirs. In a very real sense, every observer sees their own personal rainbow. As you move, the geometry changes. New droplets take over. Old droplets stop contributing, and the rainbow appears to move with you. This is why no one can ever walk up to a rainbow, because it is not fixed in one location. It exists only through a perfect alignment between the sun, the water droplets, and your eyes. By now, you may have noticed something unusual. Every rainbow we have shown so far appears as an arc. A graceful semicircle painted across the sky. But that shape is hiding a secret. A rainbow is not actually a semicircle. It is a complete circle. The reason comes from the geometry we've been exploring. The colored light reaches your eyes from droplets positioned at specific angles around a central point directly opposite the sun. Not above you, not beside you, all around you. If nothing blocked your view, the rainbow would form a perfect circle surrounding that point. But we live on the surface of Earth. The ground hides the lower half. Trees hide it. Buildings hide it. The horizon hides it. What we call a rainbow is usually only the upper portion of a much larger circle. Pilots flying above clouds and skydivers high in the atmosphere sometimes witness the entire ring, a complete circle of light suspended beneath them.
The rainbow was never half a rainbow. We simply never had the right perspective to see the rest.
And now we can finally return to the question that began this journey. Why has nobody ever found the gold at the end of a rainbow? The answer is far more fascinating than the myth. A rainbow is not a physical object waiting somewhere in the distance. It has no edge, no surface, no location you can point to on a map. The moment you move, the geometry changes. The droplets contributing to your rainbow change, and the rainbow moves with you. The end remains forever out of reach, not because it is hidden, but because it never truly exists. In a strange way, the ancient story was accidentally correct. There is no treasure waiting at the end of a rainbow. The treasure is the rainbow itself. A phenomenon created by sunlight that left the sun 8 minutes earlier, by water suspended in Earth's atmosphere, and by the remarkable ability of your eyes and brain to interpret light. For a brief moment, the universe arranges itself into a masterpiece of geometry, optics, and color. And then it disappears. The next time you see a rainbow, remember this. You are not merely looking at colors in the sky. You are witnessing sunlight, revealing the hidden mathematics of nature. And that may be more valuable than gold.